name is Ellen, but most of you know that already. And let me see how this works here. Well, so the comet is coming, yay! And there is you will see a lot of sensational articles in the newspaper, and unfortunately it is not that much of a sensation. But anyway, let's first see what is a comet, just for some of you who might not know. It's basically a very dirty snowball, they say always, you know, made of rock and ice, and well, maybe not snow, something like that. And when you see a tail forming because of the solar, the solar wind coming from the sun, and the electromagnetic field is pushing it also away, you get two different tails. You get an ion tail, which is the straight one, and the sort of bent dust tail, because it goes a bit slower and it sort of drags a little bit behind. But it is always pointed away from the sun, because the sun is pushing all this stuff away from the comet, which is, when it is outside, is just a ball, or well, a potato or so size. And it can be as big as 250 kilometers in diameter, which was Hale-Bopp. Or, like this one, they say 1 kilometer, 600 meters, something like that. They don't know for sure, but it is small. So, now where do those comets come from? So you saw already that the orbit is quite elongated. And some are so elongated that they come from the Oort cloud. They sort of get into the gravitational field of the sun, or they get bumped by something else, whatever it is, or by each other, by all the particles there. And then they come at a certain point, they get caught by a star, and they go in a sort of big orbit, or kick out completely and never come back, or they're caught by Jupiter and they stay in an orbit. Now you see, don't know if you can see it, but there's the Kuiper belt, which is inside the Oort cloud, and that is where planets like, or sorry, not planets, dwarf planets like Pluto are, and the other objects that Horizon is going to now. So it is quite far. They say it's the Oort cloud is almost halfway other stars, or like Proxima and Alpha Centauri. So we assume that other stars have also clouds around it. And how are these clouds formed, like Kuiper belt and Oort cloud? Is probably from the original cloud that the sun and the solar system were created from, as it were. So this is a remnant, and it's a big remnant. Will there be bigger objects in there? We don't know. So, but in 10 million years, and in the past there were also stars coming by and hitting the Oort cloud. And in 10 million years, Gliese 710 will come by and disturb the Oort cloud as well. I have had the pleasure to meet Professor Oort myself a couple of times when I was still in Holland, and very nice man. And to tell you here about the Oort cloud sort of is really special to me. Anyway, so Wirtanen, it will be very close, as Steve said. 12 million kilometers, or well, 11.7 or something. And the problem is, though, will it be a sensation? No, because it is quite a small comet, very small. And will it be like Comet West in 1976? No.
Picture, huh?
What?
Who took that picture?
Me. Actually, this was not my second comet. I think there were some other comets in between that weren't very bright. But the first comet that I saw was Comet Bennett in 1970. And I still remember that I was 16 and I had my binoculars and I was just sort of skimming over the rooftops of the houses. And
early morning?
In the early morning.
I remember that one too.
Yeah, and I had no idea because I'd never seen a comet before, so I was looking for something very dim, right? And then I thought, well, I can't find it. And what is that star with this cloud beside it? I look at it. It was the comet, so it was quite something, you know. So I learned about comets that way. Comet West was a little bit like that too. We had a lot of bad weather in Holland at the time. It was basically in March 1976, and we had no internet, so it was all either by telephone or a fast letter that you receive, and postal services were there that you get next day delivery, right? So, and I was looking on the map and on the charts and where can you find it? Okay, well, we'll just do this. Get the camera, film camera, of course, out and my 6 centimeter Unitron at the time, and over my shoulder, walk away from the houses. Actually, my house is about here, and walk away from it, and I think, well, and some of you have heard the story already, so sorry if I bore you to tears, but I thought, well, what is that? You know, looks like the Milky Way. Oh, wait a minute, that's not the right place for the Milky Way. Oh, is it some clouds, strange clouds though? And walk away some more, and then suddenly it's attached to the comet head. So it was like, whoa, again. So I'm getting these whoa moments all the time. And the tail was about 25 to 30 degrees. A big dust tail here, went over like that way all the way. And this is the ion tail. So this was in Pegasus at the time. And this was done with slide, 100 ISO, you would say now, ASA, and just followed as much as it could with my old azimuth. So, you know, so it was quite something. This is still the biggest comet that I've seen. Okay, now McNaught, who went south, was possibly bigger than that. But I didn't go to the southern hemisphere, but a friend of mine took some fantastic pictures of that, and it had bands like that too. I hope you can see it, but it has some bands here, and it was quite remarkable to see that. But no, Wirtanen will not be like that. Would it be like Hyakutake in 1996? It had a 30-degree tail, as some of you might have seen, and it was quite a beautiful, delicate comet with a thin tail because it was mainly the ion tail. And it was very close, it was 10 million kilometers, and it was the first time I could see a comet move through the telescope with my 75 millimeter Unitron that I still had, and that was quite something, you know, like very slow, like the hand of a clock, but you could see it move against the background of the stars. So we have a good chance that we can see Wirtanen also move like that. And it became smaller and smaller that was the nice thing. So I would say, if you have a chance to take pictures of Wirtanen, you might see the same thing, even though Hyakutake was very bright and a very bright naked eye one. And this was done from my backyard in Drayton. And over Lake Conestoga, where we're going to observe all the time. And of course, this is all with film. And slowly with the reflection here in the icy lake. And slowly, and this is all on a tripod, 30 seconds. And you can see it's a little bit, the stars are stripes, but it's forgiving. Like digital is not forgiving. Stripes become stripes. It blots out on the film, so it looks more like stars. Film was more forgiving to do this on a tripod, and there we have actually here, believe it or not, that is Venus. Just outside the frame, like an idiot, so anyway, but, well, that's how it went. This is the moon, this is Mercury, Pleiades, and you see it's getting smaller, and it's going farther away, so you can possibly do that too. And here, where is it? Where is it now? Well, there's a tail here. It didn't come over the horizon anymore, and that was the last of what we saw there. So,
Which comet was that again? We were just looking at?
Hyakutake,
What year was that?
1996. And, or would it be as bright as Comet Hale-Bopp? Well, we know already it's smaller now. Comet Hale-Bopp was enormous. It was 250 kilometers big, the nucleus. And of course it blotted out with the coma because of all the stuff that came out of the nucleus, and so it was enormous. But it was also 200 or so million kilometers away from us. So if that had been as close as Hyakutake, it would have been a blazing comet in the daytime. And God knows how many people would have suicided with cold snow. So, but it would have been, I would have liked to see that, But, well, we weren't that lucky. So this is done with, by way of a barn door tracker that I can't find, so I might have dumped it, I don't know, with the moving. But yeah, it also has again the ion tail, which is blue, and the dust tail. And Wirtanen. Well, this is Mr. Wirtanen, Carl Wirtanen, and he discovered the comet in 1947. So it has been around a long time. It has a period of 5.5 years around the sun, and basically it's been coming by very often, but not that close. So here we can see basically what the orbit is, and you see how close it comes to Jupiter. And now it really comes close to the Earth. And when is that going to happen? December 16 is the time that it comes closest to the Earth, 4 days after the perihelion. So at the moment, they have estimated that it is about a little bit brighter than 9 magnitude at this moment. Anyway, here again, this will be on the 16th that it comes this close, and it actually just intersects also our plane of orbit. So this is very lucky.
Is it coming in from the south, moving into the northern sky?
Yeah, I have
Oh, okay.
I have some charts to show, but it dips down. Right now it's in Fornax, and then it comes up again. So this is one of the latest pictures. You see very vaguely a tail. And this will be on the 16th of December. So there's different things there in the sky.
What time was that, that sunset?
That's a good question.
Judging by the moon phase, it's probably...
Yeah, it's in the sunset. Yeah, indeed. So so it becomes more favorable to see it in the evening sky. And as you see, it's dipping down now, October going to November. And, oops. And, yeah. And then here, December 1, 5, and so forth. It's moving pretty fast. It's whipping right through here. And this is Cetus, and here's the whale, basically, right? And then whipping through 12, 15, 20, and there we have Christmas. So it's moving very fast, and as you see, that's Taurus. So it's, and it goes right by Capella. So it will be quite something to see. If we have good weather, please.
Mid-December?
Better than October.
At least no mosquitoes. Just fix your butt up.
It'll be clear at full moon.
Yeah. And of course we're in the city, so we really should go out of the city to see this. So they estimate a possible 5.5 or so magnitude. 5 magnitudes if you're lucky. That is just through your binoculars. It will be barely naked eye, and Marie knows that I'm getting very, sometimes she's mostly the one that's impatient, and I was this time very impatient with seeing Giacobini Zinner when we were in Bayfield. And we were up all night, and finally at like 2:30 or so, looking through a telescope, she says, I got the comet right here. I say, where is it? I couldn't see it. Well, just keep on looking. You always tell me to keep on looking. I said, well, if that is it, that is very disappointing. And I was all indignant because I've seen some really nice pictures that were taken with simple equipment. And I expected more, and but that has been, it was really on the out. And the good pictures have been taken a couple of weeks earlier. So, well, anyway, what can I say? I was very disappointed at the time, and I think this will be maybe a bit better. But don't hold your breath. Have telescope, have binoculars, and have a lot of patience. And keep on looking, because what I found is that, you know, if you keep on looking at those fuzzy kind of objects, your retina almost starts to work like a film, or, you know, it's gathering the light, as it were, and you move around a little bit, and you start to see more. And it's amazing what you can see if you have just a little bit of patience. That's a key thing. So what can we do? You know, as amateurs? Well, you can image. You can image basically the coma of the thing. You can also image that you see the whole tail as much and far as possible. So then you have longer exposures, or you stack or whatever. Which I understand. I've never done stacking. I'm a total beginner with digital. I only made single shots with digital. I've not stacked before. Basically because I don't have an equatorial mount that works. Anyway, so I understand that the stacking for comets is a special thing that you have to do, and you have to fiddle with it. But it can be done, and you get more details out of it. The tail will change. It will reflect the magnetic field that is being carried by the solar wind of the sun. Sometimes knots appear in the tail. Sometimes it looks like something is dislodged from the comet and is also going away from the sun. And very interesting. You see, what is so interesting about comets is they're unpredictable. Yeah, we know their orbit. We can sort of guess what the brightness will be, but we don't really know. It can suddenly become bright for whatever reason because something is dislodged into this dirty snowball and will evaporate much faster. It might suddenly fizzle out and become dimmer than we expected. They're a little bit like cats, and they have tails too, you know? So you can take different exposures of the head of the comet and see something like the envelopes and the little fountains that come out if you do a large magnification. So that is what you can do too. It's really interesting what you can see. But you can also just watch. You can watch through the telescope and see these features as well. And don't hesitate to use at times a larger magnification because you will see more of the inner coma. And then you can start to estimate magnitudes. And that can be very useful, even though they have now electronic ways of doing it. But, you know, it might be clear here and somewhere else not. So anytime you can do an estimate of magnitude is still useful. And we will come back on how to do that. Then you can measure the coma diameter. If you have a micrometer, in your telescope, you can actually see how wide it is, and that is also useful. Then you can estimate condensation, basically how diffuse it is, or how almost stellar the coma is, that there is no nebulosity hardly. And they go from a range of 0 to 9 with that. To estimate magnitudes of stars, you can go to the AAVSO, the American Astronomical Variable Stars Organization or Society, and they basically have charts which show stars, and they show stars with a double digit. 65 would be magnitude 6.5. They don't do the point, guess why? Because you might confuse that with a star. So you have to understand that is how they depict magnitudes. Now if you get two stars that are close in magnitude to the target, in this case variable star, then you divide the tenth of magnitudes and say, okay, how close is the brightness of the star to to the one star and versus the other star. And then you can come as close as 1 to 2/10 of a magnitude. So, and they have a whole method for that. And I have here the links to different useful sites. And this site, they are going into how the International Comet Quarterly Organization basically advised what method to use for comets. Because the problem with comets is that they're diffuse. So what they actually advise is to defocus your telescope so that the stars also become diffuse. And then you start comparing that with the comet for brightness. It's a bit more complicated. But after a while, actually you get the hang of it, and I would say it can come as close as 2/10 of a magnitude to estimate the brightness of a comet. And here are the helpful links, and I have them here. And if you want to get maps, I should have said charts. Sorry, my Dutch came crawling in again. It's by Shop Plaza by Reiner Bauma, who was one of the co-founders with me and a bunch of other friends in 1976 when we started the Comet section in the Netherlands. And yeah, I'm ancient, that's true. So if you're interested, please ask on the observers group, ask me questions now, whatever. I can always update you on the observers group what is going on. I might even do a very small talk next month what is going on, because then we will be past it. I don't know, do we have anything in December? No?
December, I'm not sure, we have to say that.
No, but in November you do, but then the
November,
kids are here. And
When the kids are here, it's gonna be a tight schedule.
yeah, well, I can do like 2-minute update
Yeah,
or so.
sure, sounds good.
Sure. So that's it for now, and I hope it was a bit useful. And if you're interested, I have the handout with links here. So.